Okay, today we're going to be focusing on translating expressions, equations, not so much inequalities. We'll do that in class tomorrow. But translating just means writing. So given a phrase or a word problem, we're going to want to know how to decode that word problem and figure out what algebraic expression or equation they're asking us to solve. So a lot of keywords today, a lot of writing today. So just take your notes out and get ready. Okay, so a lot of writing today. We're going to focus on keywords that when you see them in these expressions or word problems, I want you to automatically understand and automatically know what operation they're talking about. So let's first talk about some addition keywords. If you see the word plus, I hope you know that means addition. That's an easy one. So anytime you see plus in any form, in a word problem or in just a statement, that's obviously going to mean addition. Total. And this is usually also going to mean that we're dealing with an equation. But total is also going to mean addition. Sum. That's an important one. That's one that sometimes we tend to forget. But sum is going to also mean addition. Increased by. Also addition. More than. More than. Anytime you see any of these words in any sort of word problem or expression or statement, it's going to mean addition. Now let's get to subtraction. Subtraction, an easy one would be minus. You also have decreased by. You have difference. And this one, like sum, is a word that sometimes we tend to forget. But difference is going to mean subtraction. Now these, I want you to just put something by these to kind of make a note, because these are ones that we're going to look at a little further later on in this video. But less than is important. It means subtraction, but it's different from these top three. And same with this next one I'm about to write down, which is subtracted from. So subtracted from is going to mean subtraction. Obviously, subtraction's in the word, is in the phrase, but it's going to be a little different. So, for example, minus. If you see minus, you're going to be subtracting left to right. So if you have a word problem that says 7 minus 6, that's going to be 7 minus 6. Okay. Or if you have a word problem that says 5 decreased by 4, that's going to be 5 minus 4. So it's left to right. Whereas with less than, if we have a word problem that says 6 less than 7, it would be 6 minus 7. We're actually taking the 6 from the 7. 6 less than 7 would be 7 minus 6. So it's kind of like subtraction in reverse. We're going to reverse the order of the numbers, and we're going to get to that in our when we get to our turnaround phrases in just a moment. So multiplication, some words that would mean multiplication. One that's obvious is times. So you see times in any word problem, that's going to mean multiplication. Product, it's going to mean multiplication. That one's important. Of, so of is usually going to mean multiplication. Most of the time, this is a word that most of the time you're going to see next to some sort of variable or unknown. So it usually means that we're multiplying a number by a variable. Twice, it's going to mean multiplying by 2. Same with double. Double is also going to mean that we're multiplying by 2. Triple is also going to mean multiplication, but we're multiplying by 3. All these mean multiplication. For division, we have an obvious one, divided by. Separate, that's going to mean division. Quotient, and this one's an important one that we tend to forget. So that quotient's going to mean division. Half. So half would mean divided by 2, or you could also think of it as multiplying it by 1/2. Same thing. Same with third or fourth or whatever. Any fraction really. It's going to mean multiplying or dividing it by the denominator, or you could just think of it as multiplying it by that fraction. So these would be some of your division keywords that I want you to jot down on your notes. Okay, parenthesis phrases. So let's take a look at this, and I'll write an example here for you. Okay, so here we have times the sum of. Times the sum of. This would actually be a phrase that would require parentheses. And let me give you an example. Maybe that'll help you visualize this. So here we have 8 times the sum of a number and 6. So what are we multiplying by 8? Are we multiplying 8 by a number? Are we multiplying 8 by 6? Or are we multiplying 8 by the entire sum of a number and 6? Well, in this case, we'd be multiplying 8 by the entire sum of a number and 6. Okay, it's 8 times the sum of a number and 6. If it would have said 8 times a number and 6, or if it would have said the sum of 8 times a number and 6, then it would have been 8n plus 6 or something like this. But the way it's worded, because we have 8 times first and then the sum of a number and 6, this would actually look like this: 8 times the sum of a number and 6. We would first have to find the sum of that number, and remember, sum means addition. So in this case, anytime you see something like that, times the sum of, it's going to mean that we're going to need parentheses. We're going to need parentheses around part of our expression. And this would also apply with difference. So if it would say times the difference of, we'd know that we would need parentheses. So these are some phrases that would require parentheses when we're writing out our algebraic expression or algebraic equation. Turnaround phrases, and this is what I told you to take note of just earlier. So some of our turnaround phrases are anytime we have then, like less than, that's going to mean that we're subtracting but in reverse. So 7 less than 8 would be 8 minus 7. You just flip the order around. Same with subtracted from. Whoops. So that would also flip the order around. So 4 subtracted from 9 would be 9 minus 4, not 4 minus 9. Let's do a few examples. Here it says the product of a number and 10 increased by 1. So please try to do this on your own before you continue watching the video. Okay, so first we have product. So product is going to mean multiplication. Now what are we multiplying? And notice the comma here kind of separates this. This we're going to look at later, because that comma there kind of separates the last part of the statement. But it says the product of a number and 10. That means we're multiplying a number that we do not know, so we'd use a variable. We could use n, and we're multiplying that times 10. So when you're multiplying a number with a variable, you could just put it right next to that variable. That means multiplication. Then, and that's where that comma comes in, then we're increasing that by 1. So then we're adding 1 to it, because increased is going to mean addition. So that would be 10n plus 1. So first we're multiplying a number in 10, and then we're increasing that by 1. Okay, so now we're going to go ahead and translate an equation. So we're going to have an equal sign. And how do I know we're going to have an equal sign? This word right here, is. Anytime you see that word is, it's most of the time going to mean that we're dealing with an equation. So an equation, if you recall, is when two expressions are equivalent to one another. So this is kind of breaking up my statement, where the left-hand side is going to be one of my expressions that would be on the left-hand side of the equal sign, and the right-hand side would be my other expression, which would be on the right-hand side of the equal sign. So let's take a look at this. It says the product of a number and 3. So product again means multiplication. Number, that means we're dealing with a variable. We don't know the value of the number yet. So it would be 3 times, let's just use n. That's going to go on the left-hand side of our equal sign. So next we have, after is, we have the sum of that number and 6. So let me circle some of these words. The sum of that number and 6. So it looks like we're using that same unknown, so therefore we have to use the same variable. We used n before, we have to use n again. And sum is going to mean addition, n plus 6. And you could go ahead and move the n's to the same side. We usually like to have our variables on the same side. We're not going to do that now, but this would be the translated version of this equation from this statement. That's it. So tomorrow we'll go over more of these. We'll look at your keywords a little bit more, and we'll talk about how to translate inequalities as well. But before tomorrow, though, I want you to go ahead and try to translate as many expressions and equations as you can. Take about 5 or 10 minutes to do that, because when I check your notes tomorrow, I'm going to be looking for more expressions and more equations translated on your notes. If you want to try the inequalities as well, you can. If not, you can just wait till tomorrow and work on those together. But I do expect to see at least some expressions and some equations translated. I will see you tomorrow. Have a great night.